Okay, so today I want to talk about the different ways in which atoms can differ from each other. So atoms are made out of protons, neutrons, and electrons, and there's many combinations of those to make different atoms and different types of atoms. So first off, I want to show you a little simulation that we're going to be playing with today. Okay, so this is a simulation called Build an Atom. Essentially what you do is you build an atom out of protons, neutrons, and electrons. So I can add a couple of protons in here, a couple of neutrons, they form together in the nucleus here, throw some electrons in there, and I have an atom. This atom is actually helium. Okay, it's a helium atom. If I click on the element here, it tells me it's helium. All right, so what happens if I change the amounts of protons, neutrons, and electrons here? Well, the first way atoms can differ here, there are three ways atoms can differ from each other. The first one is different numbers of protons. Okay, so if I add another proton, now it is an element of lithium. Another proton, it is beryllium. Another proton, it is boron. If I take protons away, it goes back to those original ones. If I go down to just one proton, now it's hydrogen. Every time I add or take away a proton, it is going to be a different element, right? So protons, when you change the number of protons, it is new elements. Elements are essentially determined by how many protons you have. Now, let's just add two protons back in here. It is helium. If I add a neutron to it, it is still helium. If I add another neutron to it, it is still helium. If I add another neutron to it, it is still helium. Changing the number of neutrons does not change which element it is. If I add more electrons to it, it's still helium. If I add even more, it's still helium. The only thing that changes from one element to the next is the number of protons. Okay, neutrons and electrons do not matter when determining what element it is. All right? So what does change if you change the number of the number of neutrons in here? Protons changes which element it is. So I'm going to start with helium again. We're just going to deal with helium here. If I add a neutron in there, it's still helium. Okay, I'm also going to throw in some electrons just because. So it is still helium here, even with one neutron. Two neutrons, still helium. Three neutrons, still helium. Well, what is changing here is actually the mass. Okay, this nucleus, which is where all the mass is, electrons don't really weigh anything. This nucleus is getting heavier and heavier with each and every single neutron. So if I actually look at what the mass is right here. I have a mass number of 5. That means 2 protons and 3 neutrons. Okay, if I were to add another neutron in there, now it's heavier, it weighs 6. If I were to add another neutron in there, it's heavier, it weighs 7. 8, every time I add a neutron, it gets heavier, but it doesn't change what it is, it's still helium. So this is an atom, this is actually carbon, it has 6 protons. Okay, and this atom has 6 neutrons and 6 electrons as well. Okay, we're not going to talk about the electrons right now. The 6 neutrons that are there, plus the 6 protons are in the nucleus, so that means that this atom weighs 12. The electrons don't have any weight, so they don't count for the mass. So the mass here is 12. This would be called carbon, and it weighs 12. This is what we call isotope symbol. I've got the symbol of carbon here, and then in the upper part of it, I have the mass, the total mass of the nucleus, which is protons and neutrons added together, and then below that I actually have the atomic number. Okay, so this is something called the mass number. It's protons and neutrons, and this is the atomic number, which element it is. Essentially what you get from this is 12 is the number of protons and neutrons added together, and then 6 is the number of protons. This is another atom of carbon. Okay, this one has 6 protons, so it's still carbon, and 6 electrons, but this time it's got 8 neutrons. Right? It is possible to have carbon atoms that have 6 neutrons, 7 neutrons, 8 neutrons, 9 neutrons. There are lots of carbon atoms in the universe we discovered that have different numbers of neutrons, even though they're all carbon and they all have 6 protons. Okay, so in this case, because it's got 8 neutrons and 6 protons, that adds up to 14. So the mass of this atom is 14. The mass number here would be 14. Atomic number is still 6 because it's still carbon. So protons and neutrons in this case, 14. All right? To figure out the number of neutrons, all you would have to do with any atom is if you know the mass number, which is protons and neutrons, and you know the number of protons, you just subtract the number of protons from the mass number, and it tells you how many neutrons you have. If you don't know, you can have those two pieces of information and figure it out. Okay? Now, both of these atoms are going to be inside of any sample of carbon. So if I pick up a random sample of carbon, a diamond ring, for example, the diamond in there will have carbon atoms in it. Some of them will be carbon with 6 neutrons. Some of them will be carbon with 8 neutrons. Some of them will be carbon with 7 neutrons, and some of them will be carbon with 5 neutrons, and some of them will be carbon with 9 neutrons. There's a whole bunch of different carbon atoms in the universe. They all have 6 protons, though. So they're all carbon, and they're all going to behave identically. They're going to react chemically. Like there's no difference between them, except that they have different masses. All right? These are called isotopes. Isotopes means you have the same element, but it has different numbers of neutrons. So carbon here, same element, 2 different atoms, but they have different numbers of neutrons. Okay, therefore they have a different mass. Those are called isotopes. Now we name isotopes after their mass. So we call this one carbon-12 and this one carbon-14. The 12 refers to the mass of the carbon atoms, and then we would call the other ones carbon-14 refers to the mass of those carbon atoms. So what happens if you change the number of electrons? Well, I'm going to start with 2 protons and 2 neutrons, so we're going to have helium here with the 2 protons, but then I also have 2 neutrons, so it's helium-4. All right, that's the isotope we're dealing with. If I throw in 2 electrons to match the protons, what I have is a normal helium atom. Now, electrons, they are outside the nucleus, which means they can actually be changed in a chemical reaction. The protons and neutrons can't change in chemical reactions. So they can only change in nuclear reactions, which we're going to get to in a few days. But the electrons can change in a chemical reaction with a chemical change. So with chemical reactions, you can either add more electrons in, or you can take some electrons away. They can move around because they're not in that nucleus. And what that changes is it changes the charge, okay? Right now, with equal protons and electrons, it is a neutral atom. If I add an extra electron in there, it gets a negative charge. Now that charge is going to be written in the symbol up here in the upper right corner. So right now, since I have 2 extra electrons, so 4 electrons total, 2 protons, positive 2 and a negative 4, add them together, you get negative 2. That's the difference between them. So it would have a charge of negative 2. If I were to take some of these electrons away again in the chemical reaction, it becomes neutral, doesn't have any charge. But then if I remove one, now it has 2 protons and 1 electron, okay, positive 2 and a negative 1. So it actually has more positive now, so it's a positive 1 charge. This atom would be positively charged because it has more protons than electrons. So here we have a lithium atom which has 3 protons and normally would have 3 electrons. Okay, it has 4 neutrons in this picture, by the way. But the normal atoms have equal protons and electrons, and since the protons are positively charged and the electrons are negatively charged, that +3 and that -3, they cancel each other out, giving the whole atom no charge overall. It's just a neutral atom without any charges, positive or negative. Okay. However, if in this atom here you have different number of electrons than protons, you would get what's called a charged atom, right? In this case, it'd be lithium, and it would have a +1 charge. Why +1? Because we have 3 protons, 2 electrons, so a +3 and a -2. +3 and -2, add them together, you get +1 left over. It's the difference between them that gives you the charge. Okay, now the charge is going to be written in the symbol. It's going to be written in the upper right. And it's either going to be positive or it's going to be negative. Okay, so make sure you include that a positive sign or negative sign when you're writing that charge. Here's another example of a charged atom. This is actually the element fluorine. Okay, so 9 protons, and it's got 10 neutrons in there. This one, though, has 10 electrons. Okay, so atoms, they can actually chemically react with things and gain electrons or lose those electrons. In this case, it's gained an extra electron. So it has a -1 charge. How do you figure out the charge here? Well, it's got +9 from the 9 protons, and then it's got -10 from the 10 electrons. +9 and -10, add them together, you're left over with -1. If they're not equal, then you're going to have an unequal amount when you add them together, and so you get that charge, that -1 charge. You have more negative in this atom than positive. Okay? These type of atoms are called ions. Ions is any atom that has lost or gained an electron. They're not going to lose or gain protons. The electrons are the ones that chemically react, and they either go to other atoms, or they're getting the electrons that come from other atoms, and so they gain them or they lose them, and that makes an uneven amount of protons and electrons there, causing a charge on the atom. Now, when we write the symbol, you may have noticed that it still has a 19 and a 9. Again, that's the mass number and the atomic number. So we have 3 pieces of information in this symbol: the mass number, the atomic number, which is the number of protons, the mass number of protons and neutrons, and then we also have the charge, which tells you if you have a different number of electrons than protons. So if there is a charge there, the electrons do not equal the protons. Right? If there's nothing there, then they do. So the 3 ways that atoms can differ. Quick summary here. Things that happen in the nucleus. Elements. You have different elements. This means you have different numbers of protons. Electrons and neutrons don't matter when determining what element it is. Isotopes. You have the same element, but they have different numbers of neutrons. So they have the same number of protons, and assume the same number of electrons, but they have different numbers of neutrons, and therefore they're going to weigh different. They're going to have different mass. Outside the nucleus, inside the nucleus, you can only change those with a nuclear reaction, which we're going to get to in a few days. But outside the nucleus, you can do this with a chemical reaction. You have ions. Ions is anything where you've changed the electrons. You either have gained some electrons or lost some. And now the protons, which didn't change, and the electrons are uneven. So you're going to have a charge on that atom. So quick summary here. 3 ways that atoms can differ: protons, neutrons, and electrons. Elements, isotopes, and ions.